Hi everyone, today in Integrated Math 1, we're going to be going over Chapter 3, Lesson 3. Here are the objectives. Make sure you write them down in your notes. Alright, so this week we're going to be talking about the rate of change. If x is an independent variable and y is a dependent variable, then the rate of change is the change in y over the change in x. And you may have heard it referred to as finding the slope, the rise over the run, which is also known, just like we said, the rate of change, which is also known as the change in y's and the change in x's. So you can see here, we will always want to start with the change in y's. So in this case, we would go up. And then to find our change in x's, we would go to the right in this case. But let's actually try an example so you can see it for yourself. So let's go over example 3. We want to find the slope of the line that passes through 0, -4, and 3, 2. So we have 0, -4, and 3, 2. So first thing I want to do is I want to use it in a formula, but the way it is, I'm going to get them mixed up with which numbers need to go where. The way I remember is the first x, the first y, the second x, the second y. Notice the 1's are together and the 2's are together. This is very important to not get them mixed up. Then let's write down our formula. M is equal to the change in y over the change in x, but there's actually another formula that will help us even more for this. It's going to be y2 minus y1, all divided by x2 minus x1, the change in y over the change in x. And it really doesn't matter which one you chose to be your 1's and your 2's, as long as you are consistent. Like I said, the 1's with the 1's and the 2's with the 2's. Now let's plug in our information. We have m is equal to y2, which is 2, minus y1, which is -4. Make sure you show those two negatives. There's a minus, and the number we have is -4. Alright, then we have x2, which is 3, and then we have x1, which is 0. Alright, then we could do our changing the signs here, which is equal to 6, divided by 3, which simplifies to be 2. So our slope is 2. But let's say we just want to change things just so you see that it doesn't matter which one you choose as your 1's and your 2's. So now let's go ahead and just try it the other way, as if we started with the 2's first and then the y's. Just flop the order. So m is equal to y2, which is -4, minus y1, which is 2. And then we're going to subtract x2, which is 0, minus x1, which is 3. -4 minus 2, you can add a plus between them, and now you see that we have a -6. 0 minus 3 is -3. Divide those, that will give us a 2. And if you recall from before, our slope from before was also 2. So you can see that it really doesn't matter which ones you choose for your x2's or your y2's, as long as they stay consistent. 2's with 2's, 1's with 1's. And that's it.